Everyone to please take your seats as we begin the next session. The next session talks about resilient space and digital networks for future multi-domain operations. As warfare evolves across land, air, sea, cyber and space, resilient space-enabled networks are becoming central to multi-domain operations. This session explores secure communications, RF intelligence, electronic warfare, geospatial awareness, and integrated sensing enabling operational coordination, spectrum dominance, and mission reliance in contested environments. I would like to invite the chair and moderator, Air Marshal G.S. Bedi, retired, and the speakers, ABM Pawan Kumar, retired, former Director General, Defence Space Agency, Colonel Harinderjit Singh, Director, Geospatial Intelligence and Imagery Analysis, DIPAC, Mr.Sireesh P, Co-founder and COO, Red Balloon Aerospace, Commodore S.K. Pujari, Chief Technology Advisor, C2C Advanced Systems. I request the delegates to please minimize movement during the session. And please keep your mobile phones on silent. And also request all the speakers to keep their remarks concise and within the allocated time. I now hand over the proceedings to the moderator. Thank you, sir.
Hello. Yeah. Good afternoon, distinguished guests, esteemed panelists, ladies and gentlemen. It's indeed a privilege to welcome you all to this session, one of the most consequential dimensions of modern military power. Resilient space-enabled networks in multi-domain operations. As warfare increasingly unfolds across land, air, sea, cyber, and space, the ability to connect sensors, shooters, decision makers, and command nodes securely and seamlessly is no longer a support function, it is core combat capability. Today's discussion comes at a time when the battle space is becoming more contested, more connected, and more complex. Secure communications, we all heard, RF intelligence, electronic warfare, geospatial awareness, and integrated sensing are not isolated disciplines anymore. Together, they form the backbone of operational coordination, spectrum dominance, and mission resilience in environments where disruption, deception, and denial are constant threats. What makes this topic especially important is that the future fight will not be won by platforms alone, but by networks that can survive under pressure, adapt in real time, and continue to function even when adversaries attempt to jam, spoof, blind, or isolate them. In that sense, resilience is not merely about redundancy. It is about assured connectivity, trusted data, rapid decision superiority, and the ability to maintain operational advantage inside highly contested electromagnetic and space environments. Our panel today will explore how emerging architecture in space-enabled communications and sensing are reshaping force design, operational planning, and joint warfare. We will also examine how militaries can preserve spectrum superiority while building systems that are secure, interoperable, and scalable for future conflicts. I am assured and confident that this session will offer valuable insight through our esteemed panelists. I will introduce them one by one as we come along, and I have with us now my first panelist, Air Vice Marshal Pawan. He is our former Director General, Defence Space Agency, one of the credible agencies that Indian Air Force instituted along with cyber and special divisions operations. AVM Pawan will highlight the importance of PNT in space situational awareness and how all this networking or resilience networking is going to be effective in multi-domain operations. Over to you, Pawan.
Thank you, sir. Thank you so much. Good afternoon, ladies and gentlemen. First of all, I would like to thank SIA for giving this opportunity to be here and speaking on this very relevant panel discussion, that is resilient space and digital network for multi-domain operations. So before I come to specific space technologies, I would take a minute to mention about multi-domain, why multi-domain, how space is affected, and since the audience here is industry and academia, how industry and academia can collaborate and contribute. Now, when you talk of multi-domain, you can primarily divide it into three broad categories. One is physical, which comprises of air, land, and sea. Second is virtual, that is cyber and space. And third is cognitive, that is human mind, which one can say that it is information building or narrative building. So when you talk of multi-domain, primarily you want to integrate and synergize different sensors, shooters, command and control centers in air, land, and sea domain to accelerate the decision cycle as well as to come to an optimum result. Now, if we scan around us, whether you talk of Russia, Ukraine, or you talk of Iran, US, or you talk of any other conflict, one thing is very clear, that it is not possible for conventional forces to operate without space and without space-related technologies. Rather, space has become a part of us, whether we talk of civil and military, because what happens is, as far as military operations are concerned, you start the operation with intelligence and you end the operation with intelligence. So you image a target to decide how to go to the target, and you end with the battle damage assessment of imaging a target. So everything happens in space domain. ISR I will not cover because one of my co-panelists is covering. But when you talk of all the technologies in this domain, it is important to understand that whatever we develop, no nation can afford separate military and separate civil. So we have to talk of dual use technologies, we have to talk of technologies that are for societal good, that are for global good, and also for military operations, and believe me, it happens like that, provided we do plan it like that. So when we talk of these technologies, first technology that comes to my mind is PNT. Now, whether we talk of any application on the mobile, whether we talk of missile, we talk of the aerial platform, any platform on the sea or on the land, everything moves with position and timestamp. So whatever we do, it requires a position and a timestamp, and hence the importance of PNT. It is just not possible to do anything at present, both in civil and military domain, without PNT. And that brings us to the topic of the Navik constellation that we are planning, and we are hopeful as a country we will have the base layer another about 2 to 3 years. But what is important is, since the civil industry is sitting here, we have to have a LEO constellation, and more importantly, we have to integrate LEO constellation with GEO constellation so that we get lower CP and we get the global coverage. Also, we require the testing of the entire equipment. So I really do not know how many of you are aware that we have recently opened a Center of Excellence for PNT in IIT Tirupati, which has got state-of-the-art facilities, whether you talk of antenna test bed, whether you talk of White Rabbit, you talk of the coming test ranges, simulators. So I think as a country, we are very fortunate that now we have opened that Center of Excellence. PNT as a whole, if we say the opportunities for the industry, I think user segment is one. Whether we talk of what you carry in the cockpit or what you carry as a soldier, user segment is one that civil industry can really invest in. Once you do have position and time stamping, then the entire backbone of multi-domain operations is communication. I will not add what has already been covered in the previous panel. Just to add to that, keep in mind that communication is one. There's a huge gap area as it also came out. Whether we talk of connecting 14,000 villages that do not have any connectivity, whether we want to have a parallel backbone of satellite communication, but satellite communication is one that we are really looking at, and this is a gap area. We are looking at multi-orbit. What came out in the previous panel discussion, we are looking at an integrated grid of LEO, MEO, and GEO. We are looking at software defined. It has to be agnostic. Whether we talk of service, whether we talk of orbit, whether we talk of frequency. So it has to be agnostic, software defined, low latency, high redundancy, and integrated grid. And that is something that we are looking at. So I think that is an area where the industry can really collaborate. Cyber, it came out very clear, the kind of the kind of threat that is there. So there is a huge scope when it comes to space segment, ground segment, link, user, or the communication segment for the communications. Because we are talking of multi-domain operations now, and everything depends on space, so it is but natural that we have to know the position of own satellites and know the position of enemy satellites, and hence the topic of space domain awareness. So that is once again a topic where there is huge scope in development of systems, whether we talk of space-based, ground-based, telescopes, radars, so on and so forth. So to sum it up, I will say that PNT, communication and space domain awareness, these are the main factors which do affect multi-domain operations, and there is a huge capability and I think a lot of work that we need to do together as we sit along here. So that is it, sir. I'll rest my case here. Thank you.
Thank you very much. Thank you. You made important points, and in fact, I wanted to pick up from the last session also. A point came up of spectrum. AVM Pawan also said that you will have to have spectrum for military use, for civil use, and in the last session it came up that this spectrum can be better optimized through AI, etc. But the fact is, our policies need to be in line with that. And when we come to spectrum allocation for defense, of late, there have been repeated cases of where government tends to annex defense spectrum because the civilian use is increasing. And I always argue that, you have to see that what is that civilian spectrum being used for. Nowhere in the world spectrum or data is as cheap as it is in India. In USA, UK, or even Australia, Canada, it's between $5 to $6 per GB. Here you can buy data for a cup of coffee for an entire month. And what is it being used for? Mindless scrolling, reels, etc. You don't want your soldier to be competing with a viral video when it comes to crucial data transmission and tomorrow's networking operations. And the history is full with examples where in Iraq war, Iraqi freedom or the Gulf War, certain operations came to a naught because the spectrum was overloaded. 255% usage was overloaded, and they say that the rescue of downed pilot Bedi would have been compromised if whole lot of data was not immediately made available to the defense forces. So something we need to look at it, that do we need government policies which rationalize use of data for civilian? Yes, it is required for your day-to-day requirement. Only that much can be made free, and let's put premium on data for just entertainment. I mean, it's just a thought. And now, let me come to the next speaker, Commodore Pujari. Commodore Pujari is Chief Technology Advisor, C2C Advanced Systems. He has over 40 years of wide-ranging experience in the Indian Navy and NTRO. Wide-ranging experience in conceptualization, design, development, and integration of software-intensive systems. And now, Commodore Pujari, you would know that challenge before us is not merely one of acquiring emerging technologies, it's one of establishing an implementation framework that transforms disparate technologies into a coherent system of systems capable of delivering persistent situational awareness. Your intervention on this, please. Thank you. Yeah, please. And we stick to about 7 minutes, right?
Thank you, sir.
Thank you.
We'll do that. Good afternoon. At the outset, I would like to thank SIA for providing me this opportunity. I will be speaking on the need for implementation of a framework for exploiting emerging technologies in the domains of resilient space and digital networks. The obvious question is, why do we need a separate implementation framework when procurement processes or infrastructure already exists? One may argue that all we need is to understand these technologies, initiate new procurement cases, or suitably modify those already underway. Unfortunately, it is not that simple. From our discussions here and also in the conference at large, it is evident that these technologies are highly complex and span the entire spectrum of modern warfare fighting capabilities. When we talk about multi-domain operations, it has already been explained by previous speaker. It is evident that these technologies are that no system can afford to operate in isolation. Every system, regardless of its complexity or level of deployment, must be able to, firstly, generate a comprehensive situational awareness picture of its area of operation and share that operational picture across the command hierarchy up and down. Please recall the famous photograph of President Obama and his team in the White House Situation Room during the operation against Osama bin Laden. The operational picture was being compiled at the point of action and was simultaneously available at the highest level of the nation's combat hierarchy, the Supreme Commander and his team. That is the challenge facing every system we procure today. That is, every system must function as an integral component of the country's broader situational awareness and decision support infrastructure. This is a demanding requirement, and I firmly believe that it cannot be achieved unless the services and the security agencies are provided with a framework that helps them understand the larger role each system is expected to play. Without such a framework, procurement will continue to occur in isolated silos. Let me illustrate this with an example of a recent proof of concept project undertaken by us at C2C Advanced Systems for one of the services. The objective was to develop a C4ISR system at the tactical edge. This called for integrating drones, surveillance cameras, and digital communication nodes in a composite operational picture. Lab testing was successful. However, during field trials, we discovered that the customer's drone transmitted encrypted video and telemetry, making integration impossible within the available time frame. We had to immediately deploy an alternate drone to complete the demo. This seemingly minor incident highlights a much larger challenge. Procurement decisions taken in isolation often create integration barriers that become apparent only during deployment. A comprehensive implementation framework can help prevent such issues from arising in the first place. The approach, and as has been referred by previous speaker, I am one of the previous speakers, I am proposing essentially a center of excellence or a COE, but with a much larger aim in mind. Two outstanding examples from our own history are the IITs and Delhi Metro Rail project. Both began with a limited scope, demonstrated success, and subsequently became models for large-scale national adoption. A center of excellence for resilient space and digital network could similarly be established at the level of a brigade, or a fighter squadron, or a naval fleet, or a tactical battle group. While limited in its operational scope, such a COE would not be limited in its technological scope. It could demonstrate the effective integration and exploitation of the full spectrum of emerging technologies relevant to this particular domain, and in doing so, provide a proven implementation model for wider adoption. Now, what does such a center of excellence entail? Firstly, it requires a dedicated team of system engineers with in-depth domain knowledge. It requires the ability to architect complex software-intensive systems. It requires a thorough understanding of system engineering and software design and development standards, that is IEEE 12207, DoD standards 2167 alpha, or MIL standards 498. The COE must also harness the ability to capture detailed system requirements and map them to the system architecture. Also, the fine art of capturing internal and external interfaces so that each software module can be designed, developed, and tested independently. The famous independent swim lane concept in action. To understand the scope of the proposed COE, let us look at a real-life C4ISR situation. A space-based radar satellite detects an enemy threat, processes it, and downlinks the coordinates using CCSDS or DVB-S2 protocols to a ground station. The ground station uses JREAP protocols to inject those targets tracks into a global military satellite backbone. Finally, a forward deployed theater gateway converts these JREAP packets back into Link 16 or Link 22 format, populating the thread directly onto the heads-up display of a fighter jet, or into the combat system of a naval frigate, or into the operations room of an infantry brigade. Now, one of the key challenges of the COE would be to develop software modules for each of these protocols, or maybe many more as technologies evolve. No foreign OEM in the world can give us these modules, not because they can't do it, but because these are to be tailor-made in line with our war-fighting doctrine and concept of operations. As the time is running out, I would like to conclude my part by requesting all the stakeholders, and particularly the decision makers present here, to take into consideration the crucial need for establishing such an implementation framework, wherein all the emerging technologies in the field of resilient space and digital network could be imbibed in right earnest. We have a proprietary architectural framework at C2C Advanced Systems. We could discuss that in detail subsequently as time permits. Thank you.
Thank you very much, Commander Pujari. Yes, Center of Excellence are required because you need to continuously train people, minds, and innovate. In all this, whether it is Situation Room where President Obama is sitting, or our own infantry brigade, or whatever, if data has to flow, data is continuously at risk. Data is at risk at source, data is at risk during transmission, data is at risk when it is being delivered. So data security needs no special introduction. Yes, vision definitely lacks. When we talk of, the point came up, quantum secure communication, it is just, brushed aside or, mentioned in a passing, which is going to be a serious threat in the future. And invariably, the threat is not so important or potent in itself. Let me draw an analogy from, let's say, when COVID came, it created massacre sort of thing and, mass scale casualties. The danger in COVID virus was not so much in potency of COVID as in the absence of antivirus. Moment the antivirus or something to deal with it came into being, then the situation was brought under control. And today, if you Google which is the most killing disease, it still would say heart attack or cancer, because you've developed an antivirus system for that. Similarly, if quantum are going to threaten your data security of the future, and if you do not wake up to post-quantum cryptography as of today, thinking that it is one of those Y2K problems and will just come and pass away, then we are in for serious trouble. Because it happens that we generally focus, more on the system and not on the threat. Take the case of UAVs. When UAVs was being developed, everybody was focusing only on UAVs and no anti-UAV system was being looked into. With the result, the kind of havoc they created in various wars, initially they became talk of the town, they still are. But the problem is the security against that, which I think they give you still time to develop anti-systems, but data or this quantum threat on your network is something which is not going to give you much of time. And if the network security is that important, then I think we need to look at it. We come to the next speaker now, Colonel Harinderjit Singh. He is Director Geospatial Intelligence and Imagery Analysis at DIPAC, one of our premier institutes in the domain of ISR. And he will, talk about MDOs in the context of two-front with fusion of various sensors in sovereign GIS. Over to you, Harinderjit Singh. About 7 minutes, please. Thank you.
Good afternoon, everyone. I would like to thank SIA. I'm very fortunate today that we have very eminent persons, General Pannu, Air Marshal Bedi, and AVM Pawan. Most of the things which I am going to speak, we were practically doing under the guidance of Pawan sir when he was my DG Defense Space Agency. When you talk about geospatial intelligence, just take your mind to what happens at Ukraine war or what is happening in USA-Iran war. You must have seen the satellite imagery where the movement of troops is being indicated on top of that by use of AI, which is denoting the type of equipment being used, the movement of forces from place A to place B. All these things are happening in real time today. So, in traditional warfare, what we used to do was we always prepare IPB, what is known as in preparation of battlefield. So you use all the available sensors, available sense in the realm of radars. You talk about human intelligence, you talk about sensors of satellite imagery, whether it is EO, SAR, you talk about IR, all those domains. So once you talk about EO and SAR, we were controlling most of the satellites of EO and SAR. EO will give you the pictures as you see each other, but it has got its own limitations. Limitations in terms of the weather, limitations in terms of the dew, or so 6 to 7 months in a year across the terrain where we are, most of the times 6 to 7 months we are not able to use EO satellites because of the weather conditions. So the use of SAR is to mitigate that, and what we use is SAR plus EO to get a coherent picture. So you use all the available data sensors into the GIS. GIS is a very important factor. You use all the data fusion into GIS, and GIS, Geospatial Info System, it gives you the knowledge which can be calibrated into the data sets which can be used by all commanders in the chain, like what is applicable to a lower level commander, he should be able to see only that much of picture. The senior commanders will see a larger picture, and the senior general who has to take the final decision will get the coherent picture of the whole battle space. Now, once we talk about data, data is the gold mine today. How you use the data is the available data sets are being used primarily from the LEO space today. all the satellites are being, the data is being fed from the LEO. But once you talk about persistent surveillance, technically what is happening is we have got two orbits. One is the SSO and the inclined orbits. Now both have got their own limitations. So it has to be a combination. Once you talk about getting a persistent surveillance, the architecture has to be so developed that you get the best possible from the SSO and the inclined orbits. If you see the terrain of our western neighbor, and the SSO orbit is the best possible to get the data. But if you talk about the eastern neighbor, because of the terrain, and the sun synchronous orbit will give you very limited data. So what you use is maximum of inclined orbits. So how much satellites you put in the inclined orbit or you put in the SSO orbit will have their own limitations. You will have blind spots in inclined orbits, but limited availability of data in the SSO orbits. So what you do is you have to have a constellation with a mix of SSO and inclined orbits. Within that also, if you are going to go for, which everyone talks about, the spatial resolution of 25 centimeter, 30 centimeter, if you are going to go with the best possible resolution, the swath of the satellites is going to be very limited. Maximum what you get today is about 6 by 6 or 8 by 8 kilometers. So if you are going to map the country with the persistent coverage of say even 12 hours, every 12 hours, it is not going to pay you dividends. So what you have to have is a mix of say very large swath, 80 kilometers, 90 kilometers, 100 kilometers with a spatial resolution of about say 1.2, 1.3 kilometers, 1.2 meters. And whichever, if you are able to detect something, you can go for the better resolution, that is 25 centimeter, 30 centimeter, to get a coherent picture. If you are going to use 30 centimeter, 25 centimeter resolution satellites all across, you actually require about 800 to 900 satellites to map the whole area. So the limitations of mapping and the economy, what we have, my take is that you have to have a combination of very large swath and combination of EO and SAR both. Now, EO gives you better clarity. SAR, because of its own limitations, especially in the hilly terrain, will give you some limitations. So what you do is, when it is difficult to image through EO, you have to have fusion of EO and SAR data. This fusion, we were piloting. So what happens is, you may have some latency of EO, means the image may be say 2 days old, 3 days old. You put the latest database of SAR, get a fusion of data, and you get the real-time picture. Now fuse this data in the GIS with the latest available UAV coverage, human int, and you get a coherent picture. Now another problem which AVM Pawan talked about was the base layer. Base layer, I have been part of various operations, and where in my formation, my RT journal told me that I have got Pinaka missiles and I'm going to target a particular objective. You give me 6-figure grid reference. I always used to tell him, sir, I can give you 10-figure grid reference, I can give you 20-figure grid reference, but what is the accuracy of that data is a question mark. So if you don't have a very accurate base layer, you may have the best of the data, best of the spatial resolution data, it is not going to give you dividends. What is required is a very accurate base layer. Now within the base layer what we have, the question of X and Y planes is very clear. Now the importance of Z, that is the height. Height, most of the time we are talking about the planes, but when it comes to targeting some objective in the hilly terrain, say in Leh Ladakh, the value of Z is very important. So what we have been asking the academia, civil industry is you give us softwares or you give us values where databases where we can get the accurate Z value. There is a pilot project which is going on in IIT Kanpur on the same. So my request from the industry is large swath satellites, more data, actionable intelligence, and XYZ plane accuracy. Thank you.
Thank you. No amount of time can ever be enough for professional like Colonel, and he would like to talk on and on because ISR is an interesting subject. You know, what he brought out, persistent surveillance, required and sun synchronous orbit or inclined orbit. A broad analogy is that we in India today, when you see, we have a credible reconnaissance capability, but we do not have persistent surveillance capability. The difference is that reconnaissance means someone has to tell me that something has happened somewhere. Can you confirm whether that has happened or not? Now I go there. It's like having a torch in your hand. You know, someone has to tell you something has fallen there or something is there. Can you please confirm? So I can have a look at the torch with a torch and, confirm it. Okay, yes, it is there or not there. But if you want me to observe continuously this room, that, what happens in this and I, detect, then you don't need torches, then you need floodlights like this. So do we have the floodlights available where we are watching continuously all our area of interest and, wherever there is an object of interest, then we can see it better. Now, what he mentioned that wanting to see everything with 25 centimeters, 30 centimeters, ultimately you're doing surveillance for what purpose? It is eventually for targeting. Let's say, put it in simple terms, targeting means not really with an aim to put a bomb or destroy or even to observe, but let's say I want to target that place with a missile or a bomb. So when you want to target a place, laser beam, for example, your laser sight seems to be the best option. That you can, if let's say from a jail compound, if there was a prisoner escaping, you want to take him down, with your gun, laser beam is the best option to take him down. But can you surveillance or put a surveillance of the entire jail with laser beams? I mean, you will need how many of them? You need a floodlight which guides you to a particular area of interest where you can use the laser beam. So hence the combination of, your wide swath, larger spatial, geospatial sort of distance, 1.5 meters, 2 meters, that is debatable. And then slowly coming to one very small area which you need to watch with 25 or 30 centimeters. Thank you, Harinder. And now we come to our last speaker. We have Mr. Sireesh P. We somehow couldn't touch base earlier, so I would request Mr. Sireesh, he is co-founder and Chief Operations Officer, Red Balloon Aerospace. Please introduce yourself and your intervention on the relevant topic.
Thank you, sir. Good afternoon, everyone. And thanks to SIA for providing this opportunity here. And at Red Balloon Aerospace, we are developing near space platforms, which will act as a bridge between airspace and space. And indeed, this whole thing started like 2 years back when I was listening to Air Marshal Bedi. So the same concept, he was speaking in DefSat, like where we have the, the focus light as well as the spotlight. Okay, and with which we started thinking, and on that day, the discussion was more on the HAPS platforms, high altitude platform systems. And unfortunately, it is quite difficult to develop any system in that particular near space because the environment is very harsh in that particular zone, especially into the stratosphere. And that got us into thinking, and over a period of time, we thought about the whole thing. And at Red Balloon Aerospace, we developed these platforms. So we develop high altitude super pressure balloons and also aerostats, and finally airships. And quite recently, on May 27th, we launched India's first super pressure balloon. And with that, we are one of the select few countries which has the capabilities of super pressure balloons. These super pressure balloons are something very important, strategically important, because they can have very long endurance, and unconventional to the zero pressure balloons or the latex balloons. Now, the balloon what we have developed, it can have an endurance of 6 months, and the latest one which we launched, we had an endurance of 7.5 hours, which we tested, and it has met all the parameters. And coming to our philosophy at Red Balloon Aerospace, like we are looking into the 4 L's. The first one is the layered. So we need to move from platform centric to the network centric. So it is not just the satellites, or it's not just the UAVs. It has to be the combination of different platforms. So different combination of these platforms, and it has to be more on the network centrics. Like we need to bring all these networks together and have it as the knowledge. And then the next point is the endurance. So typically when we speak about the satellites or the drones, they have limited capacity. The drones would be flying like they would be having for few hours. Even the male or the long endurance, 36 hours, 48 hours is the maximum what they can achieve. And these platforms, we can be there for several months, okay? And coming to the satellites, okay, they have multiple revisits and everything. They are quite good at global coverage. But when it comes to the persistent local coverage, like HAPS would be a better solutions to offer there. And the third one is low latency and high data rates, because we operate at an altitude of 20 to 25 kilometers. This is like 1800 times close to Earth in comparison to the geostationary satellites. So the latency is very, very minimum, and it is 0.3 milliseconds. And also it is quite persistent. So we can have a station keeping by operating at that altitude. So we can have that focus always like where we want to see and everything. And ultimately, it's the low cost, okay? To develop a satellite or something, it takes like very long lead times, and also it's very expensive. Whereas with this kind of platforms, we can develop them very fast, and also we can deploy them very fast. Within 1 to 2 hours, we can deploy them. And also they cost much lesser in comparison to these platforms. And our next target is to have our aerostat platforms that would be ready by August-September timeline. So we are trying to demonstrate this again from Andhra Pradesh, Vijayawada. And towards the end of this year, like we plan to have our first airship deployed. Thank you.
Great. That's, good to hear about balloons near space. And we started on this journey, and I must give credit to General Pannu. I was retiring in 22 April, and when he talked to me, I mean, I had the privilege of doing NDC course with him. And he told me that when are you retiring, I'm going to make you very busy, going to launch you in near space. And that is when we talked about near space, and DEFSAT 22 is the first one where we talked of this concept. Very, very credible, because this area that we are talking of, above 15 to 18 kilometers is till about, 70, 80 or 100 kilometers is too low for satellites. There is too much atmosphere for satellites, and it is too high for aircraft, or there is too little atmosphere for aircraft. Both the conditions are contradicting each other. So that is where these HAPs come into picture. And we have been talking of it in almost every DEFSAT. And I remember in the one before or the last, when question of dual use came up, that nowadays it was that any technology, if it has to flourish, it must be dual use. Only defense cannot make. And I remember I kind of in a lighter vein advocating that, imagine you have a near space balloon, and people do destination weddings. How about someone doing a ring ceremony in the near space, where curvature of Earth is visible, and you take your vows a little closer to God. Anyway, that's on the lighter side. But, operationally, near space still is vacant. There is so much space which is vacant, and like he said, it has a lot of advantages. Low latency, persistent surveillance of your desired area. Yes, it has its vulnerabilities, but those vulnerabilities come when there are conflicts. Most of your work in ISR is done in peace domain, when it's already the quotation that the more you sweat in peace, less you bleed in war is very much applicable for ISR. The more you work hard during peacetime to gather your intelligence, the more comfortable you are going to be in wartime. It's not when the war breaks out, you open your maps or your satellites or your sensors and say, let's see what is where. All that has to be planned and game planned and war gamed much earlier. So that is the importance of, sensors in near space, which are not being threatened or contested in peacetime, and they are doing a wonderful job. Thank you very much, everyone. And I think we started late, ma'am. You give us 5 minutes for any audience intervention. If anyone needs to ask a question or makes a quick point, we would welcome that. Thank you.
I was earlier very concerned about the use of helium for balloons or aerostat operations. But I'm told you're using hydrogen. Tell me, what are the advantages or disadvantages? Are you better off using hydrogen, or is helium a better gas to use? And would you go higher? Can you give us the differences between the two?
Yeah, sure, sir. So we are using hydrogen. Indeed, hydrogen is more efficient gas in compared to helium. Like, it will take us to the higher altitudes much faster and easy. But it is highly inflammable, so, we have a disadvantage there. Being said that, in India, we have TIFR, Tata Institute of Fundamental Research, and they've been using this like for several decades. And we have, as a country, we have got very good proficiency in terms of handling the hydrogen. And with helium, there is like lot of dependencies, and also it is 10 times more expensive in comparison to the hydrogen. So that way, using hydrogen, like we have less dependency and also less expensive.
Okay, thank you very much, ladies and gentlemen, for your patient hearing. And may I request a round of applause for the esteemed panelists, please. Thank you very much.
Thank you for a highly insightful session. I request the dignitaries to join us for a photograph, please. Please give a huge round of applause for our distinguished panel. Thank you. We will now break for tea. Please assemble for the next session at 4:40 p.m. We will start